Question 1. Again, we're going to be dealing with some trigonometry equations here, and it will be different from question by question, where some questions you could just use AS approach, just like the question last week, whereas these ones you need to use the identities that you've learned in either A2 chapter 6 or chapter 7. So here we go. Part A. So we are trying to prove that 1 minus cos 2x divided by 1 plus cos 2x will give you tan square of x. So if I'm trying to prove identities, I'll always start with the side that has something that I could simplify with. So in this case, I'll start with the left, since I know that cos 2x could be rewritten using double angle formula, which cos 2x is cos square x minus sine square x. If you apply the fundamental double angle compound angle formula, and if you just write it all in terms of cos square x, then you have 2 cos square x minus 1 by changing the sine square into 1 minus cos square x. Or alternatively, you could change the cos square x into 1 minus sine square x. So you have 1 minus sine square x and other sine square x. So it's 1 minus 2 sine square of x. So on the left, let's get started. So we have 1 minus, just use the fundamental one, cos square x minus sine square x. Same in the bottom. And now you will have 1 minus cos square x plus sine square x when you open up the bracket, divided by 1 plus cos square x minus sine square x. And then you will have on top, this part over here, 1 minus cos square x, could be changed into sine square of x. 1 and subtract sine square of x will be cos square x itself. So you will have sine square x plus sine square x on the top, cos square x plus cos square x on the bottom, which will be 2 sine square of x divided by 2 cos square of x, which means the 2 get cancelled out. So we just get sine square x divided by cos square x, which will be, as required, tan squared of x. Okay, so this is what we have shown. Now, notice that on the right-hand side, we got this expression here. So I'll walk you through what that means, but you could see that that has nothing to, that will not impact how I show this inequality, this identity. So they say x not equal to bracket 2n plus 1 multiplied by 90, okay? So if we're doing proofs since GCSE, we know that 2n represents an even number. This is how we describe any even number. So if we add 1 to it, that will be an odd. And since here we're trying to multiply it by 90 degrees, so what this actually means is that this is an odd multiple of 90 degrees. Okay, so what this means as a criteria is that x cannot be an odd multiple of 90 degrees, and with that n little e and that said, that means n has to be an integer. So this is just saying that if I pick an odd integer value for n, 2n plus 1 will be an odd integer. So I have odd integer of 90 degrees, odd integer multiplier of 90 degrees, where I don't want x to be that. So x cannot be an odd multiplier, odd integer multiplier of 90 degrees. So that is what they are saying. Okay, so you could try it with, let's say, if you just plug in 0, okay, because 1 is an odd number. If you put 0 here, you have 2 times 0, 0 plus 1, which is just 1. So they're saying, let's say x cannot be 90 degrees. You put 90 degrees here, you have 1 plus cos of 2 bracket 90 degrees. You have 1 plus cos of 180 degrees, which will give you 1 minus 1, 0. So it will cause the fraction to go undefined. So that's why here they give you a criteria of what x cannot be. So in functions terms, if we are using our A2 knowledge, so we have sort of learned that in chapter 2, so they're actually restricting the domain for this. Okay, but again, that has nothing to impact how we will prove this identity. All right. So moving on to B. So hence or otherwise. So with this hence, that means I will force myself to use this. Okay, to solve this equation, find this interval in between minus 90 to 90 degrees. Okay, so what we know is that 1 minus cos 2x divided by 1 plus cos 2x is cos square of x. So if I just look at the left-hand side of this equation without the minus 2, it does look so similar to it. Okay, as long as, but the only differences here is that on top, instead of 1 subtract cos 2x, you have 2 minus 2 loss of cos 2 theta. So that's why you could firstly, if you just play around with this fraction in part B, you could take out 2 first, and then you could apply this, which is this bit here. It's just tan square of x. So that's why for B, to start with, I will need to recognize how to use part A, in this case factor out to 2, and just apply on the fraction, which I have 2 tan squared of x, subtract 2 equals sec theta. Oops. So I made a mistake here too. It should be theta. Okay, so I can't use x, it's theta. And then now I could solve this. Remember, the interval is important. Without the interval, there will be countless answers. Countless answers. Okay, so then we shift the interval for us so that we just need to look at the things that we need to look at. Okay, so I have 2 tan square theta minus 2 equals 7 sec theta. When I have, if I'm given this sort of trigonometry equation, every single time I will look into with writing the term that is in squared. Okay, so it's the same thing since AS. So this thing, yes, you could rewrite it ever so slightly. Okay, but it won't give you anything helpful to help us to proceed solving this equation. Okay, so I want everything to be in terms of sec squared, and I could do this precisely if I just rewrite tan squared theta using this identity, which is sec squared theta is tan squared theta plus 1. That's why tan squared theta is sec squared theta minus 1. And you throw it into the equation now. So you have 2 brackets sec squared theta minus 1 minus 7 sec theta minus 2 equals to 0. Okay? So then you open up the brackets, 2 sec squared theta minus 2 minus 7 sec theta minus 2. And you have 2 sec squared theta minus 7 sec theta minus 4. Okay? And then you'll have a quadratic equation here if you make y a sec theta. So here we'll attempt to factorize this. So you have 2 sec theta plus 1 and sec theta minus 4. Okay, then you will just solve these 2 brackets, make these either one equals to 0, because in order to have these 2 multiply equals to 0, one of it has to be 0. So make sec theta the subject for both, and you solve it by doing the reciprocal. So cos theta, which is the reciprocal of sec theta, so cos theta has to be minus 2 over 1. So as this one, similarly, cos theta has to be 1 over 4. Okay, now let's look at these 2 equations here. So our interval is again in between minus 90 to 90 degrees. In this case, I don't need to change anything for my interval because it is already just in terms of theta as my argument. Argument is what I'm applying with the angle that applied by the trigonometry ratio. So the first one, it won't give you any answer because cos theta is just going to be ranging from -1 to 1. So if I just draw the graph, first one, it's not in this interval, so it's just, let's say, the one that we usually recognize from 0 to 360 to ranges from -1 to 1. On the right hand side is -2, so it's going to be a horizontal line like that, and you could see these two curves do not intersect. So that's why there will be no intersection between y equals cos theta and y equals -2, and hence no answer. And the other one now, so we're just gonna pop it into the calculator. So make sure that my it is in degree mode. So I'm just gonna do shift manual. It's the same for both CG50 and car Swiss. So change it into degrees, just double check. And then let's have a go. So cos theta is a quarter. So let me add a bracket here. So cos theta is a quarter, cos inverse of a quarter. So you have 75. That's the first answer. And the other one will be -75.5. You could do that using graphs. You can do that using a cast diagram. So you should get these two answers based on the interval in between -90 and 90 degrees. Okay, so we'll just double check by using the option cal and solving function. So we're just going to set cos of, in our case, we could only put x. So cos of x has to be equal to a quarter. So I'm going to solve this from 0. Nope, I'm just going to solve this from -90, right, to 90 degrees. Okay. And here we go. So -75.5 and 75.5. Okay, so I'm in luck. I didn't actually check the question. They say you have to give your answer in one decimal place, and I'm in luck. I just did it there without actually looking at what they're asking for. So this is question 1 for you. And so for part B, when you're approaching an equation with a hence in front, that means you should be forcing yourself to use part A. And if you factor out the 2, you'll be able to do that. And now it changes into an equation that looks like that. Whenever you have given an equation of any term, of any form, you like to have your trigonometry equation to just be in terms of one trigonometry ratio. Okay? Like at the end, you could see that I changed this equation or just in terms of sec theta. Once I've done that, then it will be smooth. Okay, so if you recall what happened last week, so in week 2, we got an equation that looks like this or something like that. So here it is already in terms of just one trigonometry ratio, just in terms of cos theta. So that's why there's no need for you to open this up using compound angle formula. If you have done that, you'll introduce more trigonometry ratios. So on the right hand side, you'll have both cos and sine right now. If you approach a trigonometry equation this way, it'll be much more work. Okay. So that's why you want to do the opposite. So keep it simple, or try to reduce your equation into one trigonometry ratio. Okay, then it will be happy ever after. Now, question 2. So we haven't done this in a long time, so that's why I decided to put this in here as a quick practice. So this is chapter 1, where we want to rewrite a algebraic fraction into partial fractions. Okay, so here they are nice. They already gave us the form. So we call that, if there's a square term in the bottom, then you need to chunking it up into this. So b over 2 plus x without the squared, and c over the 1 with squared. Right, so find the value of a and c and show that b is 0. Okay, so I could just reduce all this by multiplying through the denominator so that I could get rid of all the fraction. So I will just expand this whole thing by 1 minus 2x, 2 plus x squared. So you just imagine you just do the expansion with all these all these four terms. So therefore, the first one, you will just have 4 bracket x squared plus 6 because they will just cancel precisely. So you have a times 2 plus x all squared. The 1 minus 2x got cancelled when you're opening up the second one. Now the third one, you'll have b bracket 1 minus 2x bracket 2 plus x. And then finally is c plus c bracket 1 minus 2x. And this is an identity. That means you could put whatever x value that you want in order to solve a, b, and c. So that means you could just put, let's say, x is minus 2 to make this bracket and this bracket as 0. That helps you to find c, therefore. So if you substitute x as minus 2, you have 4 bracket minus 2 squared plus 6 equals to just c bracket 1 minus 2 times minus 2. So you have 4 times 10 and 5c, which is c is 8. You do the same again by substituting x is a half. So you have 4 bracket a half squared plus 6. And now again, if you substitute a half, b and c will be vanished. So you have a bracket 2 plus a half bracket squared. So you will have 4 times a quarter plus 6. And on the other side, you have 5 over 2 squared. So you have 1 plus 24. And you have a 25 over 4. So you have a just as 4 because on the left you have 25. With that, then you could there are a lot of ways that you could show that b will be 0. So what you could do is from here, you could just substitute x is 0 and find ABC, because we call that this is identity. That means it will work for any values of x that you put in. So if you put in 0 here first, you have 4 bracket 6 squared equals a bracket 2 squared plus b bracket 1 bracket 2 plus c bracket 1, which means you have 4 times 36 equals to 4 times the value of a that we already have plus 2b plus c times 1, where c is 8, so just 8. So you have, what's going on here? You have 16 plus 8, 24, and you won't have b 0 if you do this. What's going on here? Two plus x squared, so 4 and 4. 16 and 8, 24. That's not. Oh, okay. I found my mistake. So about that. So you don't have a square there. So this is just 4 times 6. Okay, because it is x squared. So 4 times 6. So it's just 24. 16 plus 8 plus 2b. So you have b is 0 indeed. Okay, so about that. Okay, so moving on. So now part B. Now handle otherwise. Use that to form an series expansion in assigning powers of x. You could found, so this is what we need to use the knowledge that we have learned in chapter 4, which is the negative binomial expansion. So we have found a as 4, this is 0, this is 8. That means firstly this expression is 4 over 1 minus 2x plus 8 divided by 2 plus x all squared. And in order to do the expansion, I could use the formula that we have learned before, which is the formula is given as follows. So if I have 1 plus x to the power of n, even n, if it is a negative number or a fraction, I could use this 1 plus nx plus n bracket n minus 1 over 2x squared, and it rolls on. So it keeps on going forever, but since it's just in terms of x squared, that's why I just leave it here. Now, in this case, notice that our bracket is always in terms of 1 plus something. So that's why if you have a bracket which is not starting from 1 plus, then you need to factor this out, which is if I'm doing expansion with that, I have to force out a 2, so that will change into 2 bracket 1 plus x over 2 within the bracket of 2 plus x. So if you open this up back, you have 2 plus x. So the entire thing's square bracket to the power of minus 2. So I have 8, then minus 2 as a power for 2, and 1 plus x over 2 to the power of minus 2, which that's why when you start this expansion, you should start with this form. So 8 times a quarter, which is 2 bracket 1 plus x over 2 to the power of minus 2. Okay? So this is how you should start. So we're just going to do it separately for both of them. For the first one, 4 bracket 1 minus 2x to the power of minus 1. So I have 4 in the outside. So that start with 1. So I'm okay with it. So I have 1 plus the power of n as the power is minus 1. So in order to use this, n will be minus 1. The x that they say will be minus 2x. So I have minus 1 bracket minus 2x, minus 1 minus 2, subtract 1 from the original power minus 1, divided by 2 bracket 2x squared. Okay, so let's simplify that. So I have 4 bracket 1 plus 2x. So 2 divided by 2 goes out as 1, 4x squared. So I'll have 4 plus ax plus 16x squared for the very first one. And now the second one, that will be this one that I want to simplify, 2 bracket 1 bracket x to the power of minus 2. So 2 outside the square bracket again, and this time it's minus 2. The x in that formula, in order to apply it, will be minus x over 2. So I'll have 1 plus minus 2 bracket minus x over 2 plus minus 2 minus 3, 2, and minus x over 2 all squared, which I will have 2. I think I should do best fit. It's too small now. Fit to width, I mean. So 2 bracket 1 plus x plus that will be 3 divided by 4 x squared. That gives you 3. So 6 divided by 2, 3. And that is 2 squared. Negative a half square, so a quarter. So I will have 2 plus 2x plus 3 over 2x squared. Okay, and now we are adding these two on. So I'm just going to add these two up. So I'll have 4 plus 8x plus 16x squared plus 2 plus 2x plus 3 over 2x squared, which I'll have 6 plus 10x plus that will be 8 over 2, sorry, 32 over 2, so that will be 35 over 2x squared. Okay, so that will be question 2 for you. That will be a good revision for chapter 1. Break it down into partial fraction and negative binomial. Another hypothesis testing from statistics. So there was a tree surgeon realized that she has some serious injuries at work at 48% of her years. Wow, that was not great. And then starting from 2002, she started to wear some protective clothing to reduce the risk. Okay, let's highlight that first. And then in the next 14 years, she only sustained a moderate or serious injuries during 3 years. So in part A, they suggest us to use a binomial distribution to investigate at 5% sequence level whether there's an evidence that there's a decrease in her serious injury after she has done some protections. Okay, fine. So they tell us already this is a binomial hypothesis testing. So that means we're testing for some sort of probabilities. Okay, so here, the thing that we're trying to test here is the amount of injuries that she has taken in the years. So that's why we could make it as a random variable first because we're not sure if she's injured or not. So it is the number of injuries that she has taken in along the years. So that means X could be binomial distributed because it is either one or one of the other, whether you are injured or you're not. So we have 14 years and we have a probability of P. So using that, we're going to test this using hypothesis testing. So the probability that we have in the null hypothesis is 0.48 because this is what she has discovered in along her long years. And then so we try to reduce it to see if there's a reduction once she has done some protective work. So that's why it is a lower tail test. So here, since we are not restricted to use critical region, so that's why I will use the p-value method first. But don't worry, I'll do the critical region as well. So p-value method will be, I want to just test my test statistic, which is in 14 years, we have just three, uh, 3 years of injury. So that's why as a p-value, I want to test this evidence. So I'm going to see, based on this model, what sort of probability for this to actually happen. And since this is a lower tail, so we're just going to work out anything less than or equal to this number. So probability, so p-value stands for probability value. So the probability that we have under H naught, which means I'm going to substitute p as 0.48 into this model. We'll say binomial distributed with 14 0.48. I'm just going to work out this probability. Okay, so lower tail. So these two signs has to face the same way. So I'm just going to work out this probability using the calculator. So you'll go to stats and we're going to go to distribution. We're going to go binomial, BCD. And so the lower you could put 1000 is going to be 3. And then the number of trials is going to be 14. And then 0.48. And boom, I'll get a probability for it. So 0.0399. 0.0399. Okay. And so that stands for 3%. So in order to finish the test, I'm going to compare this to the threshold, the sequence level that they gave us. And since my p-value is less than the 5%, which means that the 5% sequence level, you could take it as the threshold for us to define something as rare. But the probability of this actually happened. So that's why it is in the domain of rare. So that's why, although it is rare, it does happen. So it caused us to alternate our belief, and hence we got enough evidence to reject H naught in this case and take our alternate belief. So here you're going to say that there is sufficient evidence to reject H naught, and then you're just going to conclude with one sentence saying that the after she has done the protection, she started wearing more protective clothing, then her injuries actually reduced. More protective clothing, So the damage has reduced. Okay, so this is the p-value method. So now if I'm going to do it as the critical region method, so I'm going to do it slightly differently. So if this is the critical region method, so what I'm going to do is I'm going to start the same way, same hypotheses. H naught is equal to 0.48. H1 P is less than 0.48. So first thing first is that I need to create a region so that I'm going to reject H naught. Okay, so in order to reject H naught, my P value, the probability value, has to be less than the, the threshold 0.05. So this is the P value. So in order to design a region so that I reject H naught to start with, so my P value has to be less than 0.05. Okay, so I'm just going to find a value of C based on this inequality. So what I'm going to do then is just going to use this. How many days there are? There are 14, right? So I got that. So I'm just going to do the distribution binomial CD, and I need the list this time. And then lower list and upper list will be what you have already defined. I've already defined that. So just click OK and then just execute it. So I got these probabilities, isn't it? Let me see. Yeah, these are my probabilities, I guess. Let me just double check it one more time. So the first one, it doesn't look like it. It should be 1 here. So I'm just going to look at the table. So binomial CD, the list saved list 3. I then saved it. So save it in list 3, and then we could see. So this is my list 3 now. The probability should be here. Yep. So I'm just going to find the position where it's less than 0.05. Just more than 0.05 to just more than 0.05. You could see that that's the change in that's the change where the one before is just less than 0.05. So that means I'm just going to take x is less than or equal to 3. Okay, so the probability will be 3. So that means the probability of x is less than or equal to 3 is again the same value, 0.0399. So therefore C is 3, and which is a critical value. So that's why the critical region is going to be x less than or equal to 3. So anything that falls into the region that we designed, we're going to reject H naught. And it is precisely the case because our test statistics 3 is in the critical region. So that's why you have sufficient evidence to reject H naught. And then it will be the same conclusion. So I'm not going to write it one more time. So this is the you will have to write down one more sentence to wrap this up. Pretty much you just copy the conclusion, the test that they want you to run, which is they want you to test whether there is evidence if there's a decrease in the serious injuries. So you just rewrite it. In this case, there is. And if you do not reject H naught, then you just say there's no reduction in serious injuries. That will be it. Okay, so that's part A. And then for part B, they say state your assumptions regarding on the serious injuries that are necessary for the distribution in part A. So that means they're asking us if we could actually use binomial distribution for this test. Okay, so that means you could just recall the definition of binomial distribution. There are 4, but there are 2 literally just written here. So those 2 are, firstly, there must be a fixed probability, okay, and then the fixed number of trials. And in this test, the fixed number of trials is pretty much pre-designed for the person, so you can't really challenge that. But you could actually challenge whether or not the probability of your uh, probability is it actually the same throughout the years. Okay, so that's why in the answer they say that one of the assumption is the probability has to be constant, but our comment should be that it is not really the case because along the years, the person will get older. So that's why the probability of getting injured is not stay constant in 48%. Okay. And then it's the same sort of argument that you could use for the third assumption in binomial expansion, binomial distribution, which is that the each event, in this case, each year is independent. But it will not be the case again because as you get older, then the probability of you getting injured will increase. Okay, so that's why it's actually depend on age. It's depend on the years before it. So that's why you could just argue these 2 points for part B. And these are the answers that they suggest, which pretty much sums up what I said, I think. Question 4, connected particles. So these two particles are going to be released from rest, and Q is going to slide down, so as P moving towards the pulley. And using all the information given, the angle theta, what force on the floor, everything here, they want us to find the tension and the coefficient of friction between P and the table. So with all this, I believe we should be using Silva to solve F equals ma first. Okay, so but we'll draw the force diagram here anyway. So we have tension, the weight, 0.1 g reaction, and the friction right here. And then we have the tension, mg, and I believe nothing else for now. Okay, so say during the first 0.5 seconds of the motion, Q will move 0.75 down the plane. So slide down by 0.75. So we could use it to find the Suva first. I think it will be, so you have U is 0, you don't have V, you have S as 0.75. You want to find A, T is 0.5. So there we go. You're going to use S equals U T plus half AT squared first to find the acceleration. So half A 0.5 squared. So A will be 0.75 times 2 and times another 4. So that will be 6 meter per second squared. So next, so they want us to find the value of tension. So we're just going to form a equation of motion for Q first, because for Q there's only one unknown left, which is the tension. So we're going to resolve the weight. The weight that we want is the component that is sliding down the plane, which is going to be 0.5 g sine theta, which is 4 over 5. So therefore, F equals ma for Q will be 0.5 g sine theta minus t equals 0.5 multiplied by 6. So we have 0.5 g times 4 over 5 minus t equals 0.56. So t will be 0.1 times 4, so that will be 0.4 g minus 3 as tension. So that will be 0.4 times 9.8. Subtract 3, so 0.92 newtons. Okay. Now use that to find the coefficient of friction. Okay, so we'll do the same thing for B. So for B, that will be F equals ma. So that will be T minus the friction equals to the mass of 0.1 times the single acceleration of 6. So that will be 0.92 minus the friction equals to 0.6, which you have friction as 0.32 newtons. And then the reaction is just going to be 0.1 G again. So therefore, R, if you resolve it up and down, you get 0.1 G. So the friction, because it's already acceleration, so it has to be the maximum. So you could say as mu R. So mu 0.1 G and 0.32. So mu will be 0.32 divided by 0.1 G. So that will be 0.32 divided by 0.1 times 9.8, which gives you 0.33 if you run it to 2 seconds figure. So that is question 4. Finally, the bonus question. So it's a question that is from another service, but it's always nice to do some questions that are a little bit different from what we usually see. So here we got a function f of x as x squared, just a parabola, and there is a line that's tangent to the curve at a point that they define at minus k squared, so another letter, and there's a point C, which will come into play later, I guess. So firstly, just differentiate, nothing special, 2x. And in order to find the gradient of the tangent, which is the gradient of the curve at A, you could just substitute the coordinate of minus k into it, and you have minus 2k. So good 3 marks there. Now finally, you could find the x coordinate of B, which means, in other words, we're just going to find the equation of the straight line of L and then use it to find the x-intercept. So we'll just do y minus y1 equals m times x minus x1 for part B, which I have y minus x squared equals minus 2k x minus k. So y minus k squared minus 2kx minus 2k squared. Okay, so we'll have y equals minus 2kx minus k squared. And then you could use it by making y equals to 0. Combine these two, you'll have 0 equals minus 2kx minus k squared. K squared is minus 2kx. So make x a subject, k squared divided by minus 2k, x is minus k over 2, which is indeed what we have. Now, they want us to find the area of ABC. So the area of ABC will be this bit here, this little right angle triangle. So if we know that this is minus k over 2, so I just need the base and the height. So the base will be k over 2 here. The height is just a y coordinate of A, so k squared. So that will be k squared times k over 2, base times height, and divide that by 2. So I have k cubed divided by 4. Okay, nice and easy there. So now they want us to find the area of ABC. Given that the area of ABC is P times the area of region R, so use it to find a value of P. Okay, so in order to find a region R, then we could integrate this curve x squared from minus k to where 0 is, and take this away from the area of the triangle, which we have x cubed over 4. So the region R will be just the integral from minus k to 0 of x squared, and take this away from x cubed over 4. So we'll have x cubed over 3, 0 to minus k, which, sorry, that should be x cubed here. And then take this away from k cubed over 4. So you have 0 minus k over 3 cubed for the integral, minus k cubed over 4, which you will have, not the whole thing cubed, I should put a cubed here. So I have the k cubed divided by 3 minus k cubed divided by 4. So we have k cubed divided by 12, which is the area of R. Okay, so that means now we're just going to compare these two. The area of R is k cubed divided by 12. The area of ABC is k cubed over 4. So that means that is 3 times larger. Okay, so P will be just 3. Okay, so here you can see that this is P loss of that. So that's why P will just be 3. Okay, so that will be the final answer for question D. And this is everything that we have for question 5 for you.